In this episode we will build the logic for our item slot stack split function so we can split any slot directly with a right mouse click. Let's get started. We begin in the BPC inventory by adding a new function named split stack at slot index. This function will handle splitting a stack at a specific slot index, either automatically or by using a custom amount the player defines. We move this function to the transfer category and set it to public so we can also call it from outside if needed. Add a new input named slot index of type int. This defines which slot should be split. For example, if the player right-clicks on a slot, we'll pass its index here. Add another input named amount of type int. This allows us to choose how many items should be split off the stack, so the player can decide how much they want to move. First, call the findEmpty slot function. This checks our inventory for a free slot where we can place the new split stack. We need this to make sure the split can happen at all. If there's no free slot, we simply won't split anything. Next, call getSlotIndex on the slot index input. This fetches the slot data for the given index, so we can check its current quantity and verify it's valid. On the slot pin, add a break node, hide all unnecessary pins and expose only quantity. This makes it clear we only care about the stack amount here. Call a greater than 0 node on quantity. This is a simple safety check to ensure there's something to split. You could also use isSlotNotEmpty for this, but here we do it directly. Then promote the slot pin to a local variable named targetSlot. This variable will hold the slot data that we want to split and later adjust. Now connect the results of findEmpty slot, the isValid check, and the quantity greater than 0 check all to an operator node. This makes sure all conditions are true, so we only proceed when there's a free slot, the target slot is valid, and there's actually something to split. Finally, add a branch and connect the result of the operator node to its condition pin. This ensures we only run the split logic when everything is valid and ready. Compile and save everything once so we have a clean base. Next, promote the slot output from getSlotIndex to a local variable named sourceSlot. This stores the original slot data we want to split, acting as a template for the new slot that will hold the split amount. Now do a right-click and add a select node. We use this to decide which amount we want to split off. Right-click on the graph and call the getAmount node. This represents the value the user wants to split off the stack. Next, call a greater than 0 node on this amount value to check if the user actually entered a valid number. Then connect the result of this check directly to the wildcard pin of the select node. This means we check if the amount input is greater than 0. If true, we'll use the user-defined split value. Connect the amount input to the true pin of the select node. For the false pin, we'll generate a default split amount by dividing the quantity pin of the break node by 2. So if no custom amount is passed, the stack will be split exactly in half by default. Promote the return value of the select node to a local variable named targetSplitAmount. This is the final number we will actually split off, whether it's user-defined or the fallback half stack. Next, right after the set node for targetSplitAmount, add a branch. This checks whether the split is actually possible with the chosen value. To do this, call a greater than 0 node on targetSplitAmount. Then call a less than node on targetSplitAmount and connect the original quantity from the break node to the second pin. This ensures we never split more than what's available. Connect the results of both checks to an operator node and wire this result into the condition pin of the branch. This guarantees the split only happens if the amount is greater than 0 and less than the current stack size. A simple but safe way to prevent invalid splits. Now on the true exec pin of the branch, call the substructItemAtIndex function. This function removes the defined split amount from the original slot. Connect slot index to the getSlotIndex output and connect amount to remove to the targetSplitAmount variable. So we ensure we only remove the exact quantity we split off. After substructItemAtIndex, add a branch to check whether the subtraction was successful. If it was, we continue with adding the new split stack to its empty slot. Next, Pull in the source slot local variable and call set members in inventory slot on it. This lets us override certain parts of the slot data for the new stack. Expose the quantity pin and connect the target split amount so the new slot gets exactly this split value. Then call the setItem node to finalize the new slot's item data. Connect the struct out output to the item pin, so the modified slot struct with the updated quantity is used. For the target slot pin, connect the target slot variable we set earlier. This is the empty slot we found for placing the split stack. Compile and save everything once so the logic stays clean. Now add another function named split stack at slot. This function is used when we want to pass in the inventory slot struct directly instead of using an index, for example from a widget. Move this function to the transfer category and keep it public so it can be called externally. Add an input named slot of type inventory slot. This is the slot we want to split. Add another input named amount of type int so we can pass a custom split amount if needed. Call is not empty on the slot input to check if there's anything to split. Then add a branch and connect the result to its condition pin. On true exec, call the split stack at slot index function. This reuses our core split logic for any slot passed in. Call a break node on the slot input, hide all pins and expose just slot index. Connect this slot index to the slot index input of split stack at slot index so it knows which slot to work with. For amount, simply connect the amount input from this function. Compile and save everything, then switch back to the map view. Navigate to UI, Widget, Inventory and open the WB slot item widget. Switch to the Graph tab so we can wire up the logic directly inside this slot widget. Add a new custom event named split slot. This event will be used to trigger the split action for the slot when the user right-clicks or performs any split operation. Add a branch node right after the event. This checks if the slot actually contains an item. If it's empty, splitting obviously makes no sense. Next, right-click and call getSlotData and on it call the isNotEmpty node to check if there's something inside. Connect the result to the condition pin of the branch. If the slot is valid and not empty, we continue. Right-click and call getOwningPlayerPawn. This node returns the pawn owning this widget, in this case, our player character. On the returned pawn, call the getCharacterRef message and connect the true exec pin of the branch to it. This gives us a clean reference to our character so we can forward the split logic there. A quick note here. Normally, you should handle these kinds of inventory actions through the player controller. That's the cleanest and most robust approach, especially in a network setup. But because we started this course using the character for these actions, we'll stick with that here to keep it consistent. If you want to see a clean, advanced way to handle this, check out my MSG course. All inventory, attributes and even gas-like systems run entirely through the player controller, fully blueprint only. You'll find the link in the video description. Now we need a reroute function in the character blueprint to actually perform the split. Open the character blueprint and go to the Inventory Manager collapsed node. We'll continue the setup there. Here we add a new custom event named Inventory Split Slot Server. This acts just like the reroute we used for our transfer logic but is now dedicated for splitting stacks. We set this event to replicated, mark it as run on server, and make it reliable, because this action must always execute on the server to make sure the slot split stays valid in a multiplayer environment. Next we add an input named from container of type BPC inventory object reference so the server knows exactly from which container the slot should be split. Right after that we call on this from container the split stack at slot function to trigger the actual split logic on the server side. We then drag the slot pin from the split stack at slot function onto the inventory split slot server event to automatically add it as an input. Do the same for the amount input, so we can pass the split amount later. Now switch back to the WB item slot widget and call on the character ref the inventory split slot server event. This makes sure that when the widget wants to split a slot, the request runs through the server as well. Connect the from container pin with getInventoryRef so the server knows which container this slot belongs to. For the slot input, connect the get slot data, which passes the slot we want to split. Leave the amount pin at 0 for now, so the default behavior splits it in half automatically when no custom amount is given. Add a short comment for this logic, something like split slot, so the flow stays clear and easy to follow. Then compile and save everything once to wrap it up cleanly. Now we want to trigger this event. Open the on preview mouse button down function. Here we already have our left mouse button logic in place for dragging items. Call on mouse event the is mouse button down node and switch the mouse button to right mouse button to check if the player clicks with the right mouse button instead. Now, up at the existing branch, call on the false exec pin a new branch and connect the return value from the right mouse button node to the condition pin of this new branch. This way we make sure that if the left mouse button is not pressed, we still check whether the player used the right mouse button to trigger the slot split logic properly. On the true exec pin, call the split slot event to actually trigger the stack split when the player right-clicks an item slot. To wrap up this function properly, connect the exec pin from the split slot event to the return node, and do the same for the false exec pin of the branch. This makes sure the function always closes its flow cleanly. Compile and save everything once, and we are ready to test this out. I'll switch the play mode to play as client with 2 players and hit play to check the replication too. We start with client 1, give ourselves a few items, and run to the chest. Right-clicking on the stone inside our inventory now splits it into 2 stacks of 5, and we see the new slot appear so we can merge it back if we want. Everything works as it should. Next, we do the same with client 2. We grab some items, run to the same chest, open it up and split the items exactly the same way. We can move them around inside the storage, stack them, split them again, and everything stays fully synchronized between both clients. It does not matter if we run these actions as client 1 or client 2, everything replicates cleanly. The same goes for our hotbar. Here, too, we can split and merge items however we want. We now end the play mode and jump back to the event graph. Let's set the amount to 3. This means that every time we split, it removes exactly 3 items from the stack and creates a new stack with that amount. This is handy if you want to force a fixed split amount every time. Start the play mode again as a single player. Give yourself a few items and right-click on a slot. You'll see that every right-click now removes 3 items and creates a new stack. If the item count in the slot drops below or equal to 3, the split will not work anymore because there's not enough left to split, exactly as intended. With that, this episode is complete. I hope you enjoyed working through this step. If you did, feel free to leave a like or subscribe to the channel. If you have any questions or feedback, I'd love to hear from you down in the comments. And if you're serious about not wasting any more time on random tutorials and really want to understand how Unreal Engine works, how to solve real problems in smart ways, and how to build everything multiplayer ready, with German and English support, then check out my full course on msgcourse.com. You'll find all the details in the description below. See you in the next episode, or inside the course.